Computer Science 330 Lecture number 5, September the 1st, 2020. Today we'll be talking about the robot, actually, not a serial communication anymore. I would call it Intro to iRobot. Okay, Introduction to our iRobot Grade 2. Okay, so class updates, quiz on Thursday, everything which was shown discussed is a fair game. Everything which I'm going to show you today and showed you on Thursday last week is a fair game, but you pretty much know the routine. Okay, so that's our robot. I still keep the slide for UART. Okay, now what I'm going to do, I'm going to provide you a very short introduction, theoretical introduction. Hopefully we'll get to the practice very soon next week, to our robot. Okay, so again, our robot is going to look like this. Maybe no, it's actually, I think that we're not going to have that green thing. Yeah, I think it's going to be removed because the cable which will be attaching from your laptop to the robot is going to be, I think it's going to be over here. So I think this like plastic green thing is removed. I think they're all gray, but I don't remember honestly. Anyway, okay, so one of the things I want to show you here is this. So the company which produces our robots is called iRobot. Okay, those robots originally were created for vacuum cleaning. Okay, so some of the models of those robots have brushes, and they kind of like walk around and they use the brush and they collect the dust. Our robots don't have brushes. Our models, we don't have them, unfortunately. Okay. Now here we have a document which shows how you can download, if you have Windows computer, you can download and you create you can download a program which will automatically connect your computer, your laptop to the robot, and then there will be buttons, special buttons like left arrow, right arrow, like go straight. You push that button and that will automatically move forward. You don't have to do anything at all. Okay, so kind of like a GUI, graphical user interface. That's what's called a GUI. Okay, we're going to create our own GUI probably, and we will be doing everything manually, completely from scratch. Okay, you will not have to. So we'll definitely not be using this at all. Okay. So in order to connect our computer, our laptop to the robot, in order to solve those signals via UART interface, we're going to have to need a terminal. Okay, I hope you guys know what the terminal is. And here I provided links to 3 terminals. One of them is Windows, okay, another one is Linux and Mac. Each one of them was tested and they work properly. I don't expect that you guys are gonna have any issues. If you're using your own terminal, just be careful. It takes me a huge amount of time to set it up, or like to constantly set it up. It's a notoriously difficult process. Once you have it done like once, you understand like what buttons to push, but trying to understand which buttons you need to push, it's not trivial at all. Okay, and especially taking into account that some terminals are not made to be connected to our robots completely at all, right? So those terminals are definitely tested to be working. So I highly recommend downloading them. Serial communication documentation, and that's what I'm going to. Well, first off, let me show you this document. Tethered driving. So what does tethered mean? Tethered means there will be tethered, so like a wire, right? So you're going to connect a cable to a computer, like via USB, and to the robot. Okay. So this particular thing basically isn't like some kind of introduction, but then it gives you a set of steps which you need to do in order to basically do what we'll be doing in class, okay? Which is install Python, use PySerial. PySerial is a special package for Python to communicate via terminal. Then find creates to serial port number. It's basically like a tutorial which explains you what to do exactly, okay? And here's a short introduction to Python, okay? So that's what, and here's like a sample program. Okay, so that's what you'll be doing, like specifically this, and conclusions. Okay, cool. Then moving on over here. That's the core of what I'm going to show you today. That's the documentation. So it's iRobot Roomba 600 open interface specs. Okay. Unfortunately, I found a couple of versions of this document, and I found that some of them do not work. Some of them contain false information, and it's very unclear how they do the branding. It's very unusual how to do the model number. That's why, again, highly recommend using this one. Because if you just gonna Google iRobot Create to Manual like this, right, and then you will probably create robot. Okay, you'll probably find some kind of a user manual. Oh, open interface space. Okay, specs. So that's probably the one, maybe. Okay, so I'm not sure if this is exactly the same thing as this. Well, it looks like it. Looks like it, but I saw. No, it feels like. No, this line has different font, so that's probably a different version. Okay, so I'll be very careful. I'll be very careful about that. The one which I have in slides definitely works really well. Okay, so what I'm going to do today, I'm going to just like walk you over this document, which explains what our robot has and how it functions. Okay, very simple. Okay, so that's what the pinout. So that's the cable looks like. That the end which you connect to the robot. Okay, so there is the key over here. So you're not going to like screw up the side, right? You can insert it only one way, so you're not going to break it. Okay, so what can we find here? Number 6 is ground, number 7 is ground. Okay, it's actually normal for electrical engineering to have a couple of grounds. But then also we have RX, TX. Don't think about the D, but it's RX, TX. What does that mean? That means UART. Okay, automatically. So actually, like whenever you're looking at the controller, microcontroller, like a processor, if you see like RX, TX, boom, that's UART for sure. Like there is no RX, TX next to each other, cannot mean anything else. If you see MOSI, MISA, automatically understand it's a SPI. For I2C, what's that? I forgot. Anyway, V means voltage, power. Okay, voltage, power. Roomba battery plus, Roomba battery also plus. So 1 and 2 basically mean power. Then RxTX, then baud rate change. Okay, special signal to change in the baud rate, and then the ground. Okay, that's it. Don't need anything else. Serial port settings. Perfect. Okay, so it's very important. Whenever you set up your connection between your terminal, your computer, your terminal, and the robot, okay, there are some settings like baud rate, data bits, parity, stub bits. If you remember, those are special settings for the UART. So these are the settings which you need to use, okay, and only them. If you change one single thing, it's not going to work at all. That's why you need to be very, very careful about that. So the baud rate is 11.5200, okay, so that's how many bits. Data bits 8, right, so basically sending 1 byte per packet. Parity none, stub bits only 1, flow control none. Okay, so you can also use 19,200. We're going to use it. Okay, so method number 1, while powering off, yeah, by default communicates at this baud rate. Okay, and that's what we use in this class all the time. I've never seen anybody using this baud rate. If you're using microcontroller that does not support, then okay, yeah, there are 2 ways to force. Okay, we're not doing this. Power saving, don't care about that. Physical dimensions, that's good. Yeah, now let's talk about the modes. So this robot can operate in a couple of modes: passive mode, safe mode, full mode. That's it? No, there were more. Okay, whatever. So let's start with the full mode. Full mode is basically where you have the full control of everything in the robot. Okay, so for example, you may where is that? You see over here, there are 2 wheels. Okay, so there are 2 motors, right? Yeah, there are 2 motors. They're separate from each other. Okay, there are 2 motors. One of them spins this wheel, another one spins the other wheel. That's a bottom view. Bottom. So it's like, I don't know if that's the robot. So you're looking at the bottom of the robot. So that's one of the wheels, and then like behind that there's another wheel, and that's the top view. Okay. There are 2 motors. Each one of them controls a different wheel. And in the full mode, which means you have the full control, that's why it's called the full mode, full control. Which means, for example, if you set these wheels to spin as quickly as possible, it's gonna spin as quickly as possible no matter what. You can, I don't know, you can hammer that, you can knock it, you can just, you can lift it, it's still gonna spin. There is no way to stop it, apart from just powering it off, okay? So it gets completely crazy, so you need to be very careful about that. Usually unless you handle this last assignment, which is like the race, we usually don't mess with it. So that's the full mode. Now, safe mode and passive mode, they have they much kind of less. They give you much less capabilities, but they're much safer to operate with. Okay, so what's passive mode? Yeah, so while in passive mode, you can read Roomba sensors. Roomba has a lot of sensors, which Roomba perform as a cleaning cycle and charge battery. In passive mode, Roomba will go into power saving mode 5 minutes. To disable sleep pulse, each pulse resets counter. Okay. Upon sending the start command, we need the clean commands, but clean passive mode. Okay, yeah, so like whenever you send a start command, Roomba enters passive mode. Okay, it's very important. When the Roomba is in the passive mode, you can request to receive sensor data using any of the sensor commands. Okay, so the idea is that you're gonna send a command. You're gonna send like a command after command after command. The Roomba is going to reply with the to those commands, right? So for example, you can send a command like read the sensor from the wall. The Roomba has a sensor which kind of it sends a signal to the wall, and when it receives a reflection of that signal, okay, does a reply. So and then depending on how quickly the signal goes from the Roomba to the wall and back, how quickly, how long, how much time it takes, Roomba is going to calculate the distance between where it is now and where the wall is. Okay, so for example, if the signals, by signal I mean the light, okay, so it's infrared light, so that's kind of the light which you cannot see. It's like a very, very tiny beam of light, and if it's sent and received very quickly, that means the wall is very close. If it takes a long time, okay, by long time I mean like milliseconds or microseconds, so for us it's still like super quick. If it takes a longer time to send and receive the packet, the signal, that means the wall is really far away. Okay, so that's one of them, and then there are a bunch of other which we'll be talking about later. Okay. So yeah, so you can use any sensor, but you cannot change the current command parameters for the actuators. So basically, you cannot change the actuators. So when they say actuators, they mean motors. So you cannot change how the motors are operating. Can't do that. To something else. To change one of the actuators parameters, you must switch from passive to full or safe. Okay. So safe mode. Yeah. So basically, like if you're in the passive mode, you can't really start moving, unfortunately, right? So that's why you need to change to the safe mode or to the full mode. So in passive mode you can't really move at all. In full mode you have like complete full capability. So safe mode is a compromise. It's somewhere in between, golden middle. So that's where you guys should be. When you send a safe mode command, Roomba enters safe mode. Safe mode gives you full control of Roomba with some exceptions. Okay, so full control, but with some exceptions. Number one, detection of a cliff. So there is a so-called cliff sensor. It's located at the bottom over here. You see these two things? I think those guys are cliff sensors. What they basically do, they send also light, infrared light, down, strictly down. Okay, so when they say cliff, that means, you know, it's like when there is a cliff, there is a mountain, there is a cliff. When it's so imagine there is a cliff. Okay, so that's the sensor. Imagine there is a cliff and the Roomba goes to the right. Okay, so imagine Roomba goes that way, right? And imagine there is a cliff. Okay, like this. So at that particular moment, right, when it didn't jump off the cliff yet, but you see those, like these sensors, right? They are already don't see anything beneath, like underneath, right? Roomba stops, the robot stops, basically thinking that now it's going to fall off the cliff. And that's actually what we see a lot, because, for example, if you have a table, then we see that it's going to jump off the table. moving on. Next. Okay, detection of the wheel drop. Okay, so these wheels also kind of have the spring underneath them, and basically if let's say if it's also kind of like if one wheel is like falling off the cliff, it basically does the same thing. It automatically understands that like one wheel doesn't have anything underneath, but the other wheel does, and then it's gonna stop as well. Okay, so that's a wheel drop, and the charger plugged in the powered. Okay, so that makes sense. Okay, and you can definitely change like in between. You can go to passive mode, safe mode, full mode, like by sending a command. You can basically send a command. There is a special type of command which says like Roomba, can you please go to a passive mode? Then it's gonna change the state. Okay, moving on. Getting started the commands like 128, but we'll talk about that. Yeah, oh yes, and now we'll talk about the commands, specific commands. Okay, in order to start, you need to send the code 128. That special code with like serial sequence 128. Okay, and then you can change the mode, reset, right, stop. How to send specific commands we'll talk about later, but now let's talk about what kind of commands do you have in your disposal. Start, set, reset, stop. Okay, baud, which basically means you're gonna change the baud rate. Right, here's the table. Moving on, yes, save full. Okay, cleaning commands, we're not doing this. Yeah, sig dock, right. So by dock it means the special platform which powers up the battery. Power, schedule, okay, not doing this. Set date and time, okay, you can do that. Actuator commands, actuator means motor. So drive, that's one of them, okay, so what does it do? Check this out. Velocity high byte, velocity low byte, radius. So, what is that? Hold on. Yeah, velocity, right. Yeah, so basically what you do in this particular command, drive. So there are a couple of options of how to drive, like forward or drive kind of like forward but a bit to the left, drive forward a little bit to the right. A couple of ways of doing that. So in the drive command, in this command, so the code for this command is 137, right? And you can see that like there are 4 data bytes. The first byte is 137, and then there are 4 bytes which have the data. So when Roomba receives like 137, it understands, okay, cool. So the next thing I'm going to wait for is 4 bytes, and each one of them was going to mean something. Velocity byte and high byte and low byte. So basically what's going to happen is that it's going to accept 2 bytes, and they will be comprised into one number, and that number is going to represent how quickly both of those wheels need to spin. Okay, and now radius, high, radius low, basically also means the same thing. So there are 2 bytes, they're going to be like combined, and then Roomba is going to think, so like radius is basically which direction it should slightly turn and how slightly. Okay, so if the radius is very big, that means it needs to go forward with some kind of tilt to the left or to the right. How to do exactly, we'll talk about it later, right? If that radius is very small, that means it needs to go like immediately, like super tight turns to the left or to the right. Drive direct, okay, so that's a bit simpler. Also drives, but here we have also 4 data bytes. Right velocity high, right velocity low, left velocity high, left velocity low. Okay, so basically you have 2 bytes of data to control the speed of the right wheel, 2 bytes of data to control the speed of the left wheel. That's it. Okay, so obviously if you send, for example, if you make Roomba spin this wheel twice as fast as this wheel, right? So this wheel spins quickly, this one doesn't, right? What's going to happen? It's going to turn that way. Okay. Drive PWM, like PWM, not sure if you know what it is, unlikely to use that. Motors, what does that do? Main brush, okay, we're not using that, also motors. LEDs, okay, so it has quite a few LEDs on it, so you can control them. Okay, so that's how you would use this command. Scheduling LEDs, this one, I like this a lot, digit LED raw. So the Roomba has, I think, 4 of so-called 7-segment displays. Okay, so this display is so-called 7-segment display. No, it should be 9. No, 7-segment. Yeah, 7-segment displays. Okay, so why 7 segments? 1, 2, 3, 4, 5, 6, 7. Okay, so each one of these lines is a special LED. LED is a small bulb. Okay, and you can control each one of them separately. So you basically, like, in these commands, you can, for example, illuminate A, but keep all the rest to be off, right? In this case, like, only this guy will be lit. If, for example, you want to display the number 7, digit 7, you would illuminate this guy, and this guy, right? All the rest will be off. In this case, it will be 7. If you want to do 5, you would eliminate this, C and D. Okay, B and E will be off. If you want to do 8, you would eliminate all of them. If you want to do 0, you would eliminate all of them apart from G. 165, what is that? Digit and bits. Don't care about that. LEDs ASCII. That's actually even more useful. So you basically, what you can do, you can just send them letter A, and then it will automatically be converted into which LEDs need to be lit to show letter A. Right? You will not have to manually describe that, hey, I want to letter A, which means that I need to eliminate this, and this guy. So do not eliminate D. Yeah, so actually I see students using a lot this command. SON. There are a couple of SONs. There's actually a database of SONs which you can use. No, that's different. No. For this guy over here, basically what happens is that notes. Okay, so you can use like the music notation, notes, to play a song. So basically what you do, you send a series of bytes which represent the notes to the Roomba. Roomba saves it, and then it plays that when you just hit a play, when you send a play command. Yeah, so when you say that command, whatever bytes of data it received is going to store that, right? And then it's going to try to play the song which you gave it. Input commands, sensors. Okay, which sensors though? Oh, just sensors. Okay. Queue release, stream. Don't care about that. We'll talk about later. Pause, resume stream. Okay. Yeah. So let's talk about the sensors. What kind of sensors we have here? Bumps and wheel drop. Okay. So Roomba has what does it have? It has 2 wheels and it has 2 bumpers on the left and on the right. Okay. And then basically these bits is going to become like, is going to have different value basically. So 0 is going to is no bump, which means it didn't hit anything, and 1 means bump. Okay, so 0 means a wheel raised, right? So if this bit is set to 0, that means wheel is raised. That means there is nothing behind that, underneath that wheel. That means like in safe mode is going to stop. And 1 means the opposite. So wheel dropped. Okay, so wheel dropped, that means it's a bad situation, so there is nothing below that wheel. And 0 means wheel raised, everything is good. Wall. Okay, so there is a wall sense, and it's actually interesting. Unfortunately, like if that's kind of the circle, right? Unfortunately, it doesn't look straight. It doesn't feel the wall, which it would be straight. It goes like a little bit, I guess, 30 degrees to the right, like clockwise. And so that's why if you want to understand if the wall is next to you, you need to kind of turn to the left counterclockwise first, then sense the wall, and then turn back. Not that easy. Not sure why they did that way. Okay, so that's the wall. Cliff left, cliff front left. Okay, so that there are cliff sensors. Okay, which I showed you. Front left, front left, front right. Virtual wall. Okay, we're not using this. Overcurrents, unlikely. Dirt direct, unlikely. Unused bytes. Okay. Yeah, so that's actually an interesting thing. Unlikely to use that, but that's how the infrared sensors are going to work. You can actually change that. If you feel like, you can read this section as well. Characters, what is that? Yeah, buttons. There are a couple of buttons also, which you can also make them reprogrammable, make them to do something else, to serve them different purpose. Yeah, so temperature, it can sense the temperature. You can ask it what kind of temperature you have. Battery charge, how much battery you have, battery capacity, wall signal, cliff left, cliff front, front left, front right, cliff right, okay, charging sources available, OI mode, right, so off, passive, safe, full, so there are only 4, right. So number, plane, requested velocity, requested left velocity, lift bumper. Those are not that interesting, they're rarely used. And that is the kind of the table which summarizes everything which we talked about, okay? So here on the left you see the command, okay? Opcode, operation code, and then the bytes. If it is grayed out, that means it's not expected. For example, for start, right? We don't expect any bytes of data, just 128. If we send in the baud command, we send 129, and then we send the baud rate we want to change the UART to work with. Clean LED, so it's a separate LED. What it's supposed to do: ASCII code, baud codes, that note symbol, like one more time. So for example, A sharp, right? So A sharp, the frequency of A sharp is 233 megahertz. And the number of that node is 58. So as far as I remember, you need to send 58, and you need to send the duration of playing that. So actually you need to kind of know a little bit of music notation. So if it's like if there is a circle, right, that like small circle. If it is white, that means it's going to play for how long, right? Then if it is if it has like a straw, then it's going to play like twice as short. If it has a straw like with a tick, it's going to play like 4 times as short, as far as I remember music. Yes, and a quick reference. That's pretty much it. Yeah, that's all I wanted to show you today. Okay, I'll see you guys next time. Please prepare for the quiz and submit the notes by the end of the day today. See you next time. Bye bye.